Okay, given that the triangle ABC have three bisectors here, so this is a bisector, this is a bisector. You have to show that they all intersect, all three. So the last one here is not quite connected. Say the question is, does this actually also go to D or does it go slightly off? Right, that's the question. That's what we have to prove, that actually does have to go there if this is an angle bisector. Okay, and then also we have to show that the length of, which is equal distance from AB, BC, right? So we have to show that this, and this length, they're all equal as well. Okay, first of all, we can, if you have two lines like this, two lines, of course they meet, right? They meet at that point D. Two lines must intersect. So idea is we can first assume that AD and BD certainly meet. Okay, they meet at D. And if you draw this G, E, and F that are perpendicular from that point, you draw straight down, so it's 90 degrees, straight to AC, so it's 90 degrees and 90 degrees. Then, since, look at this triangle here and here. Since these two are equal, and these two are 90, and they share that one side, okay, all the angles are equal to each other, right? So this one here will have to equal to that because it'll be 90 minus this angle, right? 90 minus that angle is that. They're same. So you can see triangle of AGD is similar to triangle of AED, and they share the length AD. That makes triangle AGD congruent, not similar, congruent to triangle of AED. Okay, so these two are exactly the same. So similarly, you can say triangle of DEB is congruent to triangle of DFB. Okay, so these two are also congruent because they have right angles. They also share these two angles and these two angles, and they share the hypotenuse. Okay, so let's connect, right? Connect C to D. Okay, C to D. So if you connect this, will that actually be the angle bisector or no? That's the question that we want to argue. Okay, if you let G, right, D equal to H, it follows that DE is also H, right? Because these two are congruent triangles. Then it also follows that DF is also H. So this just proves that if D is the incenter, right, it's where they all meet, all three of these lengths are equal. Okay, it's because of the fact that it's connected by congruent triangles. Okay, so that means GD is congruent to DF, right? And what else do we have here? We have CD. CD is congruent to CD. It's a reflex property, okay? And then, of course, the angles are right angles, right? Angle of CGD is equal to angle of CFD. They're both 90 degrees. So they're both exactly the same right angle triangle, right? We know that if this and this and this and this is equal to each other, CG has to equal to CF. Right? Why? You can show that by Pythagorean theorem. Pythagorean theorem, right? So they have the same hypotenuse, same length. So if you use a Pythagorean theorem, you're going to be able to show that these two lengths are equal. Okay, which means therefore CD bisects angle of GCF. So it is a bisector. It's an angle bisector. Therefore, right, all angle bisectors meet at D. Okay, so I just proved that. And I already proved this, that they're all H.